Alright, so the thing that we are moving toward in this unit on vectors is we want to start applying what we know about vectors to application problems. So this video is kind of going to start to introduce, when you look at an application problem, what's the very first thing you do. But this video is not necessarily going to be about applications, it's going to be about measuring angles in those application problems. So first, before we talk about measuring angles, it'd be helpful to write down just kind of the context that we're using here for these problems. So vectors are used to represent the path of a moving object. Because a vector can describe an object's speed, which in the context of this unit we call magnitude, and the direction of the movement. Okay, so when we write a vector in terms of magnitude and direction, what we typically do is we write the vector as the magnitude multiplied by cos theta I plus sine theta j. So this would be in the AI bj form. You might also see it written like this, where it's just the component form. So I have always done the AI bj form for this, but I've seen the component form also. It doesn't really matter. So as you can imagine, cos theta would be the angle that the vector makes with the positive x-axis. So talking about standard position, which is the position we used in our trigonometry unit when we were talking about the unit circle and all that, the way that your calculator would measure angles. So cos would represent the x-coordinate, or the horizontal movement, and then sine would represent the y, or talking about that vertical component that we've learned about with vectors. Alright, so first, before we even get into this, we're just going to talk about the different ways that a problem could talk about angle measurements, and one of the most popular ones is called bearing. And the reason that we're going to learn about different angle measurements is because when we talk about, let's go ahead and draw this on our notes, when we talk about angle measurements in terms of a math class, we always start over here at 0 degrees, and we work our way around this way. And this right here is called standard position. And standard position is what our graphing calculators is in. It's what we work with exclusively in math classes and things like that. But the rest of the world doesn't really start at the positive x-axis for angles. They start at north, because that kind of makes sense. So a bearing is an angle that's measured clockwise between the positive y-axis, and here we can, let's go ahead and just say north, because the positive y-axis would be the one that goes up. So north and the vector. So when we measure bearing, we're going to start up here at north and go around this way. So north would be 0 degrees. Alright, so if we're talking about a plane that is bearing 70 degrees, that's all fine and good for it to be bearing 70 degrees, and people would look at that and they'd say, okay, start at north and go 70 degrees clockwise. That makes sense. But if we then tried to go back and plug something into our calculator here because we want to solve the problem using a graphing calculator, we could not use 70 degrees because our calculator is not set to go from bearing measurements. It's set to do measurements from standard position. And there's no function on your calculator that I know of, at least, that will convert it for you. So you just have to convert it yourself. And typically this is not a difficult thing to do. You just have to think about it. I'm not going to give you a list of formulas to memorize for this. I'm going to ask that you draw a picture and then use your common sense. So when we do bearing, we start at north and we go this way. So this right here would be 70 degrees going clockwise from north. So for us, if we're talking about the standard position, then standard position starts right here and we measure this way, and so that must be a 20-degree angle in standard position. So for us, we're going to use 20 degrees when we plug this into our calculator to check answers for things. All right, let's say we're talking about bearing 161 degrees. 161 would mean, so we're going from here, that's 90 degrees that we're bearing. And then that would mean that we have to go 71 degrees further than that. So that would be bearing 161. All right. So now we have to think, how could I figure out what this is in standard position? So what I typically do on this one is I'm like, okay, well if this is 71 degrees right here, and if I'm measuring my standard position, I'm going to start here and go all the way around this way. I would almost be going all the way back to 360, but I'm not going this angle right here, which happened to be that 71 degrees. So in my calculator, I'd be like, all right, 360 minus 71. Now, this is not the only way to solve this problem, but it is a way to get there. All right, so that's one of the ways you can think of it. So this would be 289 degrees in standard position. All right, so we'll be practicing those. Again, I'm not going to tell you a shortcut for any of these because honestly we'd have to have a different shortcut for each of the 4 quadrants. But these problems are definitely doable if you think through how the problem should work and use your common sense. Okay. Now, I gave you guys this packet because there are other ways that you can measure angles. So first, we're going to go ahead and draw a set of axes and label our cardinal directions. And then we're going to do the in-between. So we've got northeast and southeast and southwest and northwest. All right, so in standard position, east would be 0 degrees, north would be 90 degrees. Here we have 180 degrees for west, 270 degrees for south. And so directly in between, if we were talking about northeast, we would say 45 degrees. Northwest would be 135 degrees. Southwest would be, what is that, 225. And southeast would be 315. All right. So if they're talking about something, some direction like that, and they're saying that the plane was going northwest, then what they're really talking about in standard position would be 135 degrees. All right. Now, there are other ways we can name these angles. So what would it look like if you drew an angle that was 30 degrees west of north? So you would start north. You would go towards the west 30 degrees, so this is 30 degrees west of north, and then if we were to write that, we would write that as north 30 degrees west. So this means you start at north and you go 30 degrees to the west of that. All right? So if we were to write this exact problem in standard position, then that would be starting here, going up there's 90 degrees and another 30 degrees, so that would be 120 degrees from standard position. So what we're going to practice in class tomorrow is how to write all of these out. So you don't have to be perfect at it just from watching the video, but I wanted you guys to have at least some time to think it through before you were required to practice it in class.